Well, good morning or good afternoon or good whatever. Welcome back to class. This week we're going to talk about plate boundaries. So we're going to set up some generic Cornell notes like we did last week. On the left you can see that's what all the final elements are going to look like and where they're going to go. On the right, this is what I want you to set up for now. Just put whatever page number you're on in your notebook in the corner. If you don't have your notebook, just grab any old piece of binder paper, put the title across the top, which is plate boundaries, make a spot for you to write the EQ, and when you're done writing the EQ, which is on the next slide, you're going to draw a line underneath it like that, and then I usually lay about 3 fingers down, and then I just do part of the line because I don't know how far I'm going to go. So just go ahead and kind of get it started like that. All right, so I'm going to talk and then you can pause and write, okay? So listen first, write second. All right, so the title of these notes is Plate Boundaries, and all the activities you've done this week, the videos, the lab activities, the article have all been about plate boundaries. So our essential questions for the whole week have been, what is plate tectonics? What are the 3 types of plate boundaries? And what crustal features, like mountains, are formed at plate boundaries? So go ahead and hit pause and write down the title and the EQ and then draw the line underneath and then do the up and down vertical line. So you have your area, and you can always rewind the video back and see how to set that up. All right, well, as we learned last week, there's 7 continents, but it wasn't always that way. It shifted into that position. So today we're going to talk about, how the heck did it shift into that position? All right, last week we learned about Alfred Wegener, and he came up with that idea of continental drift. He knew the continents moved, there was all that evidence for it, but he didn't know how they moved. So then along comes Harry Hess, and he came up with the mechanism for how they move. It's called seafloor spreading. And he said there's hot magma, it's like lava, but it hasn't hit the surface yet, and it's coming up underneath the ocean floor. And they had the technology then at the time that they could tell that it was actually happening. So it comes up through these cracks in the ocean floor and it makes new crust and it pushes the plates apart from each other. So Alfred Wegener's continental drift theory plus Harry Hess's seafloor spreading, you put those together and you get the theory of plate tectonics. So listen first and then you can pause and write. So plate tectonics, the definition, is a theory that Earth's outer crust, the lithosphere, is divided into several plates that glide over the plastic-like and less rigid asthenosphere, or the upper mantle. Okay, go ahead and pause and write this down in that body section of your notes. Okay, let's look a little closer at the layers. So convection currents, and again, just listen and then you can write later. Convection currents or how energy is transferred in the mantle. So the asthenosphere right here, I've heard it described as like the consistency of toothpaste. So if you squeezed a bunch of toothpaste out on like a plate and lifted up the plate, it's not like a liquid, like it would just pour right off, but over time it would kind of like ooze down the plate. So that's kind of what the asthenosphere is like. And it's hot down here at the bottom, and hot things rise, and then it gets close to the top, the cooler crust, the lithosphere, and then it cools down and then it sinks. And that's what causes the plates to move, is these slow motion currents that are happening like this, is pulling on the slabs of crust, the slabs of asthenosphere, the slabs of lithosphere, and helping it to move. If you've ever been on the top bunk before of a bunk bed, it's always hot up there, right? Because hot things rise, so hot air rises, hot water rises, and so does hot rock. Oh, whoops. All right, go ahead and pause and write those 2 things down. Okay, so now let's look at that top layer, the continental crust. It's the layer of rock that forms the continents. It also forms the shallow seabeds close to the shore, where that arrow is, and it floats on top of the mantle. It's older than oceanic crust, and it's mostly made of granite. So go ahead and pause and write that down. All right, that's one type of crust. It's thicker and less dense than the oceanic crust. It kind of floats on top. All right, the other type of crust is the oceanic crust. It's underneath the ocean. That's why it's called oceanic crust. It's made of a rock called basalt. It's younger and it's more dense, so it kind of sinks down. Oh, whoops. All right, go ahead and pause and write that down. I gotta get used to this. Okay, so what happens when plates collide? They can do one of three things. They can converge, they can collide or come together, they can diverge, divide or move apart from each other, or they can transform, which means they're just sliding right past each other. So there's converging, coming together, diverging, they're dividing, that's creating crust, and transforming. You're not creating or destroying, you're just sliding around. All right, you ready for a fun song? Not quite as good as the annoying integer song, but let's give it a try. Converging is colliding, diverging is dividing, transform is sliding. We are the plate boundaries. Na 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 na. Na 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 na. There you go. You're welcome. You didn't know you were getting a song today. All right, so let's talk about the plate boundaries. So just listen and then you can write at the end. Divergent boundaries are dividing. They're moving apart from each other. If it happens between two oceanic crusts, they make what's called a mid-oceanic ridge, where it actually creates mountains underneath the ocean. And this process is called seafloor spreading. So now go ahead and pause, write this down, and add a little sketch like this. You can even just draw two squares with the arrows moving apart from each other. But to help you remember that divergent boundaries are dividing, they're moving apart. Okay, and it creates new crust, fresh crust. All right, when it happens on land, two continental crusts can diverge from each other and create what's called a rift valley. And you can see that happening in these pictures here. So they're pulling apart from each other because, you know, the mantle is moving opposite directions here. New crust is being formed right there. And then over time, it's not just going to leave a big empty space, it's actually going to fill in with water. And so we can see, like, that's how the Red Sea was formed. There's a big rift valley in Africa. It's creating new crust. And then, like I said, the rift valley in Africa. So go ahead and pause and write that down. And it will fill up with water over time. Okay, next up we have transform boundaries. Those are our movers and our shakers. They slip sideways past each other, creating earthquakes. So we're not creating or destroying crust, we're just shaking it up a little bit. We find a lot of these boundaries on the seafloor, so there's underwater earthquakes, as you read about in the article. And the most famous is right here in California, the San Andreas Fault. So go ahead and pause, write that down, and also sketch this little picture right here. All right, last up is our converging ones. And so there's a lot of different things that can happen. If we have continental hitting continental, we get folded mountains like the Himalayas. If we have continental colliding with oceanic, we get what happens in California and Oregon and Washington. We get a lot of volcanoes. If it's ocean versus ocean, we get volcanic arc of islands like the Aleutian Islands in Alaska. All right, so converging boundary, continental, like I said before. They collide. It's like when you push those two towels against each other in the Explorer activity in the labs. They collide and push against each other. It causes both plates to rise and it creates a folded mountains like the like Mount Everest. You know, some of the tallest mountains in the world happen because these two continental crusts are colliding with each other. It's not a subduction zone though. So go ahead and pause, write this down, and sketch that little picture. All right, so if it happens between a continental crust and an oceanic crust, remember the continental crust is less dense, it floats more, and the oceanic crust is more dense and it sinks. And so when they meet, it's like when you have the two colored socks that, and you slid your hands over each other with the socks on in the Explorer activity. The oceanic crust will go below. And when it goes below, we say it subducts. It sinks down and it makes volcanoes because the oceanic crust will go below. That crust material will heat up into magma and it'll float up because it's less dense and it'll melt its way through and bam, you get yourself a volcano. A trench will form along the coast right there at the place where the plates collide. And here we are, California. If you've ever been to Mount Shasta or Mount Lassen, those are volcanoes. And we have a whole chain of volcanoes all the way up through Oregon and into Washington that are formed. They're called the Cascade volcanoes that are formed because of this continental crust plus oceanic crust collision. So go ahead and hit pause and write that down. All right, so when we have ocean plus ocean, they collide and push against each other. They're the same density, but the older it is, the more dense it is. So the older one will sink below the younger one, and it'll create a volcanic arc of islands like before, but it's happening like underneath the ocean. And then over time, these little mountains and volcanoes will rise up enough to poke above the ocean surface, and we get like the Aleutian Islands in Alaska there. It's another subduction zone. Don't need to write it down though. All right, and then last but not least, we have something called the Ring of Fire right there. So what the Ring of Fire is, it's a very interesting place geologically. It's a long chain of volcanoes that surround the Pacific Ocean. Here's us right there. So we're part of the Ring of Fire. Dun, dun, dun. It's one of the most geologically active areas on Earth, and it is just riddled with volcanoes and earthquakes. And it's because there's a lot of plates, oceanic plates hitting continental plates all along here. And we got a lot of action. We got converging, diverging, and transform boundaries, and it just makes this thing called the Ring of Fire. All right, let's revisit the notes. So by now you should have your title, your EQ, your page number. You should have all that body of notes right there and your little sketches of the boundaries. So I want you to go back through and reread everything, underline or highlight anything important that jumps out to you. And then in the left-hand column over here, you're going to put any questions you still have, any guiding questions you come up with, main ideas that pop out, or vocabulary words. So, you know, plate tectonics should be like, you know, one of the definitions you have highlighted up here, one of the vocabulary words. So you should have at least 3 things in this column here. So go ahead and hit pause and make that happen. All right, and then last but not least is the summary, goes at the bottom. So use this guide to fill it out. Remember, it's going to go at the very bottom. Go ahead and label it summary, revisit your notes, and use it to help fill in the blanks. All right, that's it. I hope you enjoyed class today. Wish I could see you in person, but that's not possible right now. So congratulations. You're still learning though, so good for you. All right, see you next week. Bye.